Hello everyone. Please welcome Milan Gabor.
Okay, nice to see you at my talk. So the title of my talk is "All Your Hashes Are Belong to Us." This actually not only work from my side, but the whole team Virus was actually involved in this one. And you're going to see we made some. Well, we didn't create or invent something new, but we just take some, let's say, some ingredients, bake them, and you will see that we got some really nice results. Okay, so just short notice about me. I'm still ethical hacker. I'm ex-developer, so in my previous life I've been developer, so I know how hard it is to develop the secure code. I've been giving a presentation at BalCCon many times already, so it's always a pleasure also from my side to be again here. I'm also Always Maribor chapter leaders, and I'm B-Sides Ljubljana organizer. And just to brag a little bit, last year we had like really good opportunity, and we had been running the CTF in GITEX in Dubai for Abu Dhabi Digital Authority, and we were hosting the best teams in the world, and we had a lot of fun. And also today we are hosting the CTF, so we just started, and you may stop by later. So as I said, I'm also the B-Sides Ljubljana, so if you're next year, because this year we already had event in June, so if you're next year somewhere near Ljubljana, you're more than welcome to join or even send your submission. We are more than happy. And as I said, outside is running the CTF. This year we prepared a little bit different one, not the Jeopardy style, but the tech and defense. So we are experimenting also at BalCCon how good are not only attacking but also defending the services. And you see the game is on, and it's going to be until the 8 or 7 or 8 in the evening. So regarding the hashes, I have to thank Bojan Ždrnja yesterday for great, perfect introduction about the hashes. So I won't be, let's say, boring you what the hashes are, how the Windows is working with the hashes. But still, you know, I told Bojan that he didn't show the essence. He has been speaking about the hashes, but he didn't show any of the hashes, right? So I will do this, you know, so for those who never saw a hash, which is flowing all over the network, especially in local networks. So this is kind of hash, which is really interesting. Why? Because you have the like username, you have the machine name, you would have here the domain, and of course, what he didn't mention, it's actually also this one, this really nice numbers like 1122334455667788. Anybody know what these numbers means or why they are used? No one catching hashes. Okay, these numbers are used with special purpose. But probably you heard about the rainbow tables, right? Yes. So all the rainbow tables are compiled against this challenge. So if you change this challenge, you have to recompile or rebuild all the rainbow tables. So that's why if you see something like 1122, then you know this is like a perfect way to build the rainbow tables, or the hashes are easily then not crackable, but you just search through the rainbow tables. Okay, so these are the hashes, but why there is a problem with the hashes? The problem with the hashes is, and this is also what Bojan did mention yesterday, because inside this hash, you know, are our passwords. So actually our keys to our digital identities. And what is the problem with hashes or with the passwords? Well, if the passwords are bad and the hackers get your hashes and your password is I don't know, only 7, 8, 9 letters long, so, and not complex at all, we or the real hackers can crack it or break it really easily. So I put it here, you see the numbers from 2020 to 2023, and you see that these barriers, how fast the password can be cracked, are falling. So it depends where you are. You should be there here in this green area. But from our experience, we've seen in many of the companies, because we are doing a lot of pen tests, also internal, not only externals, there's still majority. I don't know how it's in Serbia, but in Slovenia, majority of the companies, what do you think? What their length of the passwords, average? 8, exactly. So the 8. So this means that, if you get the hashes, you can crack it almost instantly. Especially if they are not using, let's say, special characters, or even because I don't know. I never seen that somebody would use like ch or sh or j in their password, because this really makes more fun. Okay, so we have the hashes, and this is how the story started. Because on each engagement during the pen test, we are actually trying to get as much as we can hashes and then break them. Why? Because if we break it, in some cases we don't have to. You just relay them, but also system administrators are doing lately quite good job. So they're protecting the services with signing. So the relay the hashes is not actually so much more anymore. But we still get the hashes. So what can we do? And in some cases, in internal pen tests, you really want to get a lot of hashes with little, let's say, with little intervention. So you don't have to do a lot of network, because in some cases you really want to stay below the radar. So you don't want to get caught. So this is how it started. And it started actually with, I wanted to put Martin Luther King, but ABBA was also great. So I had a dream. So I have a dream, and I still remember this year when I got to the other room with with my coworkers, and I told you we try to build such tool, to catch all the hashes. So as soon as somebody touches something, you get his hash without his intervention. So that was my dream. The first they laughed a little bit, and then I started explaining my dream. How should we get this one? And then I think the first draft, so the first pieces that were put together were quite fast. I know I went to some conference, and in 1 week when I returned, they already have like small prototype that was doing such things. So what was my dream? Actually was something like this. In this case, I challenged AI, since the AI, the ChatGPT is really hot this time. So I asked, please draw Gandalf, which is catching the hashes. So this is the best the AI gave me, just catching the lightnings. But it's not so far from the truth, because it's really, I really want, to catch as many hashes without, maybe without even knowing that users are sending their hashes to me. And so it started. So the basic idea was also, if I can control what is sent to the client, because the client is sending the hashes, I can control the client. So if we try to bring this to the real world, this is really hard in some cases to achieve on a wired network. But it's easy to achieve on the Wi-Fi. Anyone here who is not connected to the Wi-Fi at the moment? Okay, cool. It's a security conference, right? This is a normal, but in normal, conferences, everybody is connected to the Wi-Fi. So the basic idea was, what if I'm that hotspot, or am I that Wi-Fi that everybody is connecting to? Can I control it with sending, the DHCP, the DNS and the proxy settings to the client. What happens? So can they send hashes automatically to me? And yes, we are trying to pursue it and build on that idea. So I was also getting from one hypothesis, okay, hands up, those guys that raise their hands that you're not connected to any of the networks. I bet that you still have on your laptop computers at least one connection to one open site. You have, right? At least one, that's my hypothesis. You have been to the Starbucks, you have been to the McDonald's, you have been to, I don't know, what kind of, no, it's not Siam. Probably you have at least one open Wi-Fi connection. And I bet that probably you have also one open Wi-Fi connection that you set in such manner that is set to auto-connect. So as soon as there is in the vicinity this Wi-Fi, your notebook will connect to that Wi-Fi. Am I true? That's the things that are working. So that's definitely probability I was playing when we were trying to build such thing. Why is this true? Because we've seen a lot of probe requests. So what are the probe requests? In this case, you see, I took one of the probe requests, not from here, so don't be afraid. No, I didn't scan here anything yet. So it's not from here, it's from our office. And you see that there are a lot of, this one phone, which was probably just moving, bypassing our office in Slovenia. You see that he had we managed to get 13 probe requests, then 14, then another one with 14. Why did I pick this one? You see, does this MAC address is a little bit weird? Yeah, probably, because this is not my normal MAC address. Probably this is kind of some strange phone. But we've seen that these are the probe requests, the phone that are sending out the probe requests to the air about the networks that he has been connected in the past, or the computer, whatever. So that was our hypothesis that actually there are a lot of probe requests, there are a lot of Wi-Fi networks, and what if we built a tool and we call it a hash catcher, because we are catching the hashes. That was our goal, try to catch the hashes. So we went, to write the recipe, what do we need to have on that, device or computer or Raspberry Pi or phone or whatever. So we started with one responder, one host APD, one DNS mask, one DHCP, one hash to police, X times hashcat. As much as hashcats, as much as graphic cards you have, the faster you will get the password. One Raspberry Pi or phone and one Alpha Wi-Fi card. So that is the main recipe. So if I ask you, probably it's nothing new, right here. We all know these components. All the hackers are using it, for different kind of purposes. But it's only the way how we put it together that makes sense. So regarding the hardware, we started with the Raspberry Pi. Why? Because it's much, it's really simple to put the Raspbian on it. We have all the Wi-Fi drivers. We did use the Alpha Wi-Fi card. In the first try, we used, because we really like this one, because they have 2.4 and 5 gigahertz. It was working in first scenario, but the second one it didn't work. Then we switched to this one. And in the first phase we had Raspberry Pi, and the second one we used Pine phone. I have it here, so I will try to do the demo if the demo gods will be, let's say, good to me. So the next one, Boyan also already yesterday told about the responder. Responder is a must tool. So if you get to any of the networks, when I have time, I normally also try to run it in a hotel networks. Why? Because it's really nice to see if they've done a good job regarding the client isolations. So it's the tool for catching the hashes. If you don't know it, just run it, responder minus capital I with interface that your notebook or your phone or your tablet has. It will try to answer to, let's say, not the probe request, but the broadcast request. And also if there's Windows machines, probably you will get soon some kind of the hashes. It's using a lot of protocols to capture the hashes, and it's written in Python and has like a lot of ports. So it's kind of also noisy. If you have like some EDR in your network, they will catch you. So that's for sure. So then we have like host APD, which is a user space daemon, just to bring up the Wi-Fi networks. Why do we need this? We will get a little bit later. But definitely, to bring up the, the Wi-Fi or even more Wi-Fi identifiers. Then there we have the DNS mask. It's actually kind of caching, dynamic host configuration, everything has it inside. So it's also a good tool, also kind of used in like different kind of configurations. I won't be telling you about the DHCPD because we all know to get an IP address. It's also used in this scenario. Then we have like hashcat. For those who doesn't know, hashcat is the must for cracking the passwords. Normally we use hashcat on different kind of cracking rigs that miners throw out, and they're still doing a great job cracking the passwords. But we have the hashcat, let's say, upgraded with HashTopolis, which is management for all the rigs. So why we are using HashTopolis? Because we are just sending the hashes to the HashTopolis, and HashTopolis manages all the agents and splitting the hashes, and doing crazy stuff. And it has really nice features. So if you tune it a little bit, it can crack the passwords really easy. And then, since we want to have, to be secure, we added also to the Raspberry Pi and also to the phone the VPN. So because we didn't want to send all the hashes just across the internet, because somebody might be also intercepting our traffic. So the final result, it's actually a hash catcher, which is normally just a bash script, 219 lines. That's it. Nothing more. It takes care for everything, installing the software that is needed since it's compiling and configuring the software and the services. It's kind of partially interactive, so when you start the setup procedure, it will ask you what kind of the network device you have, like what kind of drivers. It's at the moment we tested on the Raspberry and Ubuntu. And we have additional script to install all the Wi-Fi cards for the alpha that we are using. This one is like 55 lines of the code. So it's not much. And then we have like we set it up the two workflows. The first workflow was, what if we set up a static Wi-Fi with, for example, I don't know, McDonald's, and then somebody will be connecting it. We set it up, left it for a couple of days, and nothing happened. Why? Because you have to be quick when somebody was driving by. What would be happen? And when we were testing, the workflow was something like this. So we enabled the Wi-Fi, which was connected in some history at the McDonald's. The phone was connecting to our hash catcher device. Hash catcher was getting the IP and all the settings regarding the DHCP. This was trying to push the VPAD for the proxy settings. And when the device said, I want to get that file, then the hash catcher say, hey, you need to authenticate. And then when was it authenticated, then the windows are working in such manner that they are sending hashes freely to everybody that needs. They don't check their identity on the other side. And if you get that hashes, then their hashes are sent to the HashTopolis, And if the password is, let's say, really weak, it's cracked in like a couple of minutes. But we noticed that we have a problem because nobody was connecting for several days. Then we improved that workflow. So we went back to the drawing board. What can we do else? Then we set it up. Open Wi-Fi with host APD with mana attack. What is mana attacks? It's actually, it checks, the network guy checks the whole time in the year what kind of the probe requests are sending out. So if your phone is setting up, hey, what is my home Wi-Fi? What is my home Wi-Fi? The mana says, okay, I'm your home Wi-Fi. And then the client connects to it. And then start things rolling on. So the whole time, this host APD is checking for the clients and is setting up the networks. So it means kind of a lot of work. And the rest of it is the same. So you connect to me or your phone connects to my device. You know, I'm trying to push you all the settings. And then at one point I say to your Windows, you have to authenticate. So that was the first prototype, you know, the Raspberry Pi. We are doing some other projects. So you see this is the Alpha network card without the casing. And final result was something like this. So if you put this one in your pocket, and then you put a battery packet, and could you imagine if I would be now trying to get into through the lobby with all the guys that they have in open notebooks, what would happen? I would be catching their hashes, right? So that was the final version regarding the Raspberry Pi. Then I got the Pine phone. And now the problem was with the Pine phone that you need external Wi-Fi card. And this Wi-Fi card, we just also saw that it's kind of it has problems because if you put this card inside, you don't get enough power. Then you have to also do the external power supply, but it's working. It's working really nice. Just have to get rid of that part, you know, the big one card and the rest of it. So I have prepared a demo, but this one is pre-recorded. So while we will be seeing, just to stay. So here's the responder. So here are going to be hashes. This is the client machine who is trying to connect to the Wi-Fi, and this is the hash topolis. So if we try to see now, we just start, the fonts are too small. So first we started some open Wi-Fi with BalCCon open, and then we are tailing the logs. So this is the responder logs, and nothing happens because there is no client. Here on the Windows side, so we have like Windows client. You see that this is like various dev PC with a user. And then this user just enables his Wi-Fi in a network. So, and you see that this one network, where is open, that was sometime connected in previous time, is there. As soon as he starts, so the user starts the Wi-Fi, or the probe request gets, you see the responder immediately gets the IP address, then is doing its magic, setting up also the proxy request, the DNS request, it's serving it to the client, and then in some time, you know, since Windows are okay, there is an internet, and they start sending freely, so without any problems, the hashes to our hash catcher. How many hashes? They're sending a lot of hashes. Not just the one, but all of hashes. And here we see that these hashes are automatically sent to the hash topolis. And as soon as they get to the hash topolis, they are starting cracking there. Okay. So that's it regarding the demo. So it's so easy. Just take 5 tools, put it together, and it's working. Probably I don't have any more time with the live demo, but we can. 5 minutes. Okay, I will try to do it. So anybody want to live on the edge? Anyone has a PC, Windows PC notebook here? Who's willing to test it? Nobody? Probably you won't be getting near me now after my presentation, right? So you will be just like, go away, you know. Okay, I will try to start it and see because it takes some time. Because on this phone, it takes a little bit. Let's see. Okay, and we can follow and then just go back to the demo. So from the notes and lessons learned, what might help you, that not all the cards are working. We tested with different cards, and not all have been capable to put the card in such mode that you can actually start up the Wi-Fi hotspots. PinePhone, from our experience, is not the best solution because it drains the battery really fast. And some of the cards that are working on Raspberry Pi, they were not working on PinePhone. Something with the USB, I don't know what. We have been messing a lot of, Hashcatcher was working at me, at my coworker. He said, like, it's not working. Why? Because he was really trying to protect this device. Why? Because somebody gets to that device, then you have a problem. And he was enabling the firewall, and he didn't get the hashes. So when he turned off the firewall, he got the hashes. So in some cases, firewalls are good, and in some cases, they're bad. And also, in some cases, we have seen that when you put in the card, it's automatically RFI blocked. So RFI kills it, and you cannot start it anymore. So you have to unblock it and then move on. So definitely there are questions. Mac users, Linux users, how many users are just with notebooks? Okay. No. Are you safe? Yes. Maybe not. Maybe with some combination with DHCP and requesting something on Samba share, it might get also your hashes. We tried also with Windows machine that was joined to the Azure ID. It's the same principle as, for example, the machines that were not. It was not working. We didn't get their hashes. Maybe their corporate policy was different. I don't know. We didn't get into deep in that case, but it was not working. So what can be also possible side effects of this such project as we did with Hashcatcher? So who is using regularly Responder? 1, 2, 3. Okay. Side effect of this one was because we have seen when we are playing with it, one of our devices, IoT devices, connected it to that fake Hashcatcher access, and we got, let's say, username and passwords because it's connecting to the MQTT database. So the side effect of this project was that one of my colleagues, which is not here today, he actually made MQTT server which collects client ID, username, and the passwords of MQTT devices. So for example, you have like ESP32 as a temperature sensor, and it's connecting over the Wi-Fi, and you bring the Hashcatcher, you might get the username and the password of MQTT. So we made a pull request, and our code is in the responder. So this is kind of side effect of such projects. We didn't plan for this. It happened. We tried it. So it's our code. Our code for my coworker is also merged there. Okay, what are improvement plans? Definitely we need a better testing procedure. It's not GitHub ready, but the script is going to be. So if you ask me or my colleagues, really nicely, you can be the beta tester, or you can buy Matej a beer or two. He can tell you a little bit more. Another thing is, DIA authentication. That's why, we are thinking maybe adding additional card, or use a flipper to deauth all, and then everybody would be trying to connect in, and we will get even more hashes. Or maybe supporting even more interfaces. So for example, something like this would be really good. This is, I have my backpack. It's not ready, but it can collect a lot of things. So what can we do? Well, definitely, for example, if you don't want your hashes to be leaked, definitely use VPN everywhere, but still in some cases when the Wi-Fi is not fast, or because our Hashcatcher can provide the internet, or it can just provide the DHCP address. If we are letting you through the internet, then the VPN can be working. But meanwhile, when the VPN is starting and it's connecting, we can still get the hashes. Disable protocols. Bojan was yesterday telling about NBTS and LLMNR protocols. So if you don't know what they mean, disable it. Also on your Windows. And definitely enforce strong passwords. So if you have like 20 plus character passwords, nobody can crack it. And of course, delete known networks sometimes. Sometimes this means once per year. So and that's it. Probably we won't have time for the demo, but if you want, we can try it outside. My colleague tried before, and since there are a lot of probes, it crashed. So if you want, we can still be, but we have to be fast. So you're going to see what's happening. We are there at the table for the attack and defense. We can find us there. So I don't want to spend more time. And if there are any questions, so I won't be eating up the time for the next presenter. Any questions? No questions. It's the same in Slovenia. Nobody asks questions. If you go to America, they were like questions, but here it's the same. So, question from my Croatian friend.
So the cracking, is it brute force, or do you need to have some sort of list, or how does that go?
Hashtopolis has really good, let's say, combination. So you can use the list, combined list. You can use the mask. You can use the password that you already previous cracked. So we have like different combinations. So first one goes through the list. Then with some mask that we have, like Proljeće 2023. Or the summer 2023 or something like that in the month. And then at the end, if nothing is found, then the brute force, pure brute force. And this is, for example, I can tell you we have like 24, 25 different graphic cards, so to crack it, and it's going fast.
Yeah, my next question was if it's on the graphics card, so thanks.
Yeah, definitely. Everybody is cracking on graphic cards. We used rigs that people, when they stopped mining, they were throwing away. These rigs were quite okay for the cracking of the cards. But maybe only one remark here. One 4090 cards can replace the one rig. That's from our experience. So it's kind of, if you have some of them, you can crack the passwords even with 9 or 10 characters really fast.
First, thank you for your presentation. Here. Yeah.
Okay.
You said you were testing against Windows.
Yeah.
Does it also work for Android and
No.
iPhones?
No. We tried with Android connecting because we see when we are looking, but Android didn't send anything because it's totally different, and you cannot send it like proxies or some other features. So no.
And for other question for Hashtopolis, what rigs did you use? And how many?
I said majority of the cards we are using 1060 did that, 2 or 3 rigs from that one. But mainly since we really want to don't waste too much electricity. In the first case, we are not just using only one 4090 for the fast cracking because it's so powerful that the whole full rig of 8 cards. So.
Thank you.
Welcome. Okay, thank you very much. And if you have additional questions, you can find me outside.
Okay.